Hi everyone, I'm Julia Cataldo and I'll present my master's project today to you. It was developed together with Professor Aniela França, who advised me, and I'm happy to present here today in the symposium organized by Professors Aniela and I, because I've had the pleasure to work with them. And also, I'm also happy to present this conference organized by Professor Juliana Gomes, which with whom I've also had the pleasure to work with. So I'd like to start my presentation by thanking all of them. And now let's get to business. So my project is entitled Restaurant to Restore, an EEG study on the neuropsychological effect of diachrony in lexical access. All right, so I want to start talking about linguistic knowledge and lexical creativity. So from a young age, we can perceive meaning-making mechanisms, and we're able to reproduce them to create or understand new words. So for example, if viajante, which is Brazilian Portuguese for traveler, is someone who travels, and palestrante, which is Portuguese for lecturer, is someone who lectures, then who is a ficante, which comes from the verb ficar, Portuguese for to stay. Well, ficante, when coerced into the semantics of dating, is someone who stays with you repeatedly. So it's basically someone who you're dating, but not seriously. Then if caminhonete is a small truck and colchonete is a small, like a thin air mattress, what would be a peguete? Well, it comes from the verb pegar, which means to catch. And in the semantics of dating, peguete is someone you catch and then you let go. So someone you're dating, again, but not seriously. Um, okay, so up to now, we're just playing with suffixes for roots whose meanings we know. But what happens when you say, for example, restaurante, restaurant, which is a place where we go to eat, but etymologically, this word comes from the verb to restore, because we go to a restaurant to restore our forces in theory. And how about refrigerante, which means soda, a soft drink, and comes from the word to refrigerate? Do Brazilian Portuguese speakers understand a soda as something that cools them? Do we have access to this meaning? And my last example is liquidação, which means sale. And it comes from the word liquid, because you're turning a product value into liquid money. So this one might be a bit more transparent for those who deal with financial transactions. So how much this is transparent or opaque for you also depends on your previous experience with the language. So just as a generalization, the words on the right are morphologically derived from the words on the left, but synchronically, the ones on the left are semantically, sorry, the ones on the right. No, this is correct. I'm so sorry. The ones on the left are semantically opaque in relation to those on the right. So my research question is exactly how synchronically opaque words are processed and represented. In other words, are we interested in whether our implicit linguistic knowledge considers possible etymological relations? And those ones that we're not necessarily conscious about. Language is a very reflex process. And synchronically, we don't know the etymology of almost every word. This isn't something that we're like taught in school. So the lexical creativity we've been talking about, it happens independently of the literacy level, for example, which doesn't mean it does not increase with higher literacy levels. But given our linguistic knowledge, just as our linguistic creativity can play with morphemes and their meanings, does our parser grasp this opaque relationship between restaurant and to restore? So this is my question. And then my first hypothesis is that it does, and then it decomposes the word until its original root. So for example, the word restaurant would be decomposed until the root of to restore. And my second hypothesis is that it does not. And so we create a new lexicalized entry in our mental lexicon for words such as restaurant, and then it would only be decomposed until this new root. All right, and what do we already know in this area? Well, there are a lot of lexical processing models, and they are generally divided into the full listing, decompositional, and dual route models. Here we will take a decompositional approach, and we will also grasp a theoretical linguistics base of the distributed morphology, because we are assuming the morphemes exist and are represented mentally and neurally. There also is a history of studies with neuroprocessing of words in Portuguese, and then I'd like to draw your attention to this one in particular, who found out that morphological identity yields positive priming effects and behaves differently than morphological identity. So we do have some evidence for the for the mental representation of morphemes. And methodologically, we can see I mean, there are a lot of studies in the area, and what we can see from them is that mass priming yields equivalent priming between semantically opaque and transparent words. And this is also the case for lower stimulus onset asynchronies. So the higher the interval between starting to present the prime and starting to present the target, the harder it is for someone to decompose a semantically opaque word into their morphemes. And if you have a mass priming, that becomes a zero. So in this study, we would like exactly to get this two more complicated settings, and see if we decompose words, semantically opaque words into their morphemes in those conditions. So as methodology, we'll have a cross-model priming study, so an auditory prime and then a visual target. And the goal of doing this was to try to decrease effects of orthography, because morphologically related words, at least in Portuguese, they are very much orthographically related too. We used a very long SOA to move alongside the synchrony, just like as we just discussed. So we used 600 milliseconds between prime and target, and here it was between the end of the prime and the beginning of the target. So not the most canonical use of the word SOA, and the reason for this is just because the prime was auditory. We used an EEG to record brain data. It was a 32-channel EEG, and the electrodes were placed in the 1020 international system. Our dependent variables were the reaction times, accuracy, and mean amplitudes. And our independent variables were the type of relationship between prime and target, and the number of targets, the target's morphological layers. And I'll explain this now that I'll present you my materials. So our main interest is to know how our brain goes from a word such as estado, which means a restoring, to as a prime, to a word such as restaurante, restaurant, to a target. This is our synchronically opaque condition. And then we also added targets with a different layer, an additional morphological layer. So here we have restaurantezinho, which means just a small or little restaurant. And the goal to do this was just to see if after we access the first merge between the root and the categorizing morpheme, if adding another morphological layer to this word would produce any significant effect in both behavioral and neural data. Well, then we have to compare this to a condition in which we have an intact relationship between prime and target. So here we go from a restoring to, a restoring. So in Portuguese, it's restauro, the noun, and then restauro, the noun. This is our identical condition. But then we also added a morphological layer and got to restore. This will be our intact condition. And then we had a third condition. We need another baseline. So we had an identity baseline, and now we need a condition in which that is no morphological relationship and no semantic relationship at all. So we have a condition in which we go from restauro, a restoring, to something that has nothing to do with it, so star, estrela. And then adding another layer to a completely different word, carinhoso, so affectionate. And this is our none condition, because that is no relationship whatsoever between prime and target. We finally also had a pseudo condition, because we gave participants a lexical task, so they had to judge whether the target was or was not a word in the language. So we also needed pseudo words. So here's an example of one. So we came from vontade as a prime. So vontade means will, the noun, so it does exist, to a target as portaria, for example, which is a pseudo word. All right, these are just the codes we used. You might see them throughout the slide presentation, but I just, before showing you the experimental timeline, I just wanted to say that we had in total 48 word pairs and 48 pseudo word pairs. So each participant judged 96 trials. Then, each participant saw 8 stimuli from each condition, and the stimuli were laid in a Latin square. So this was a within subjects experiment. Now to the experimental timeline and task. Participants first saw a fixation cross, then they heard the prime, then they saw a blank screen, then they visually saw the target, and then they had to make a lexical decision, pressing either a yes, it's a word, or a no, it's not a word, in what we call the Chronos box. We had 45 students participate in the experiment, and 3 of them were excluded to the behavioral analysis due to low accuracy. So in the end, our N was of 44. Their mean age was of 23, 85 years. They were all between 18 and 30 years old, and they were all right-handed with no auditory problem. All right, so now let's talk about our behavior results. So this, what I'll show you now is a linear model that we ran, having reaction time as the dependent factor and relation type as the independent measure. And by relation type, I mean either opaque, intact, or no relationship at all. So in the y-axis, you're going to see response time in milliseconds. In the x-axis, you're going to see relation time. So the intact condition, intact relationship between prime and target, had 549 response time, milliseconds of response time mean. And then comparing this to the non-condition was much slower, which makes sense. And this difference was significant, so this was a good baseline check. And then we have our opaque condition, our condition of interest, and we see that it is significantly different from the intact condition, but not from the non-condition. So this already tells us something, right? The difference, this big difference between the opaque and the intact conditions, with the opaque being as hard to process as the non-condition. So it seems like the morphological relationship that the intact words have is different than the morphological relationship that the opaque words have. All right, so now let's see a model of morphological layers as the predicting factor. So again, time in the y-axis and number of morphological layers in the x-axis, and then conditions with one morphological layer, were much faster in reaction times than conditions with two morphological layers, and this was significant difference. So this also makes sense. It takes you more time to read and process a longer word, and it is not only longer in size, it is also longer in number of morphemes. All right, so I'm going to put this to the side, and now we're going to look at a model that has condition as the predictive factor. And by condition, I just mean the full factorial between type of relationship and number of layers. So here we have our intact condition with one layer compared to our distractor. So I remind you that the intact condition with one layer was an identity, a complete identity condition. So it was to go from, for example, to restore, the very same word. So here we have a sanity check. The condition was very different from the distractor, which was a pseudo word. And now we can compare the intact condition to the opaque condition, also with one layer. And the difference is not significant. So that is a bit different from what we just saw in the previous model. And now comparing this to the condition with no relationship at all, while the intact condition is also significantly different from this one, but the opaque condition is not. So this is similar to what we just saw. Then adding the two-layer conditions, the two-layer intact condition is not different from the one-layer intact condition. And that is also the case for the no relationship conditions, but the opaque condition of 2 and 1 layers are different between themselves. And then the opaque condition with 2 layers is also different from the intact condition with 2 layers, but it is not different from the no relationship condition with 2 layers. So in the end, we can kind of see the same pattern as before, which is, opaque conditions patterning with non-conditions and not with intact conditions. So let me put this to the side. Here I have accuracy data, and I'm not going to go into the full statistics of this. I just wanted to take a moment for you to appreciate how here we have the exact opposite of the reaction time. So this is a very well-behaved data set. So for conditions that have the lowest reaction time, we have the highest accuracies across the board. So our conclusions for the behavioral results is that coming from Gestalt or restoration, we process to restore much faster and more accurately than we process restaurant. So processing restaurant is not significantly different than processing a random word such as effectuate. So it's not significantly different than processing a target to which the crime has no relationship whatsoever. So it seems like restaurant and to restore do not share the same lexical entry. And it also seems like the addition of a morphological layer increased the reaction times and decreased accuracies. So we seem to take an additional step to process them. All right, but now let's go to the EEG results. Here we had only 36 participants because we had to proceed. We had to conduct 8 exclusions during pre-processing, and I'm happy to talk about them if you want, if you're interested. We analyzed the N per 100 time window because we believe this was the most relevant, according to what their literature says, to what we are interested in. And then we conducted linear models with mean amplitudes as the I thought this was wrong. Yes, as our response condition. And then we conducted them for each ROI. So for the frontal temporal left, frontal temporal right, frontal central parietal, and occipital. And from all of these regions, we selected to show you the regions that visually showed an N per 100 wave pattern and for which our models were significant. So those were 2 conditions that had to both be met. So in our first model, which was mean amplitude per type of relation, so intact, opaque, and none, we had this wave pattern in the central area, the central ROI. So we see the distractor very different from all the rest. This is good sanity check. And then we see that intact has the lowest N per 100, which is also good, but then opaque is almost as difficult to process. Well, not almost, but it is closer to the distractor than to the identity. Well, it's actually in the middle, but you get the sense. And it is more difficult to process than the non-condition. The same happens here in central parietal ROI with the difference that here that here the non-condition, the same thing happens in the central parietal. And then pairwise comparisons show that the intact versus opaque pairwise comparison, which is our main interest, was only marginally significant in the central ROI and significant in the central parietal. The non versus intact was significant in the central, but not in the central parietal, and the non versus opaque was not significant across the board. So we see a bit of a pattern that we saw in the behavioral data. Less convincing, but it is there. So this makes us stick to our previous conclusion that it seems that we have different lexical entries for intact and opaque items. So accessing opaque items is sometimes even more costly than accessing non-items, no relationship items. So we do believe that something like a lexical garden takes place here, in the sense that you see to restore, and then you see restaurant, and you believe it is morphologically related, but then you realize that it's not, and then you have to go back to the encyclopedia and get another lexical entry for this one. And this takes time, and here we see how costly it is. Now, a model that has condition as the independent measure. So here we have central and CP wave patterns for intact, opaque, and non-conditions with one morphological layer. And here we have central and CP wave patterns for intact, opaque, and non-morphological conditions with two morphological layers. And we can see how here the ones with two morphological layers, for them, the opaque condition has the biggest N per 100. And for the ones with one morphological condition, the opaque and the non-condition have equally high N per hundreds, and they differ from the intact morphological condition, the identity condition. Our pairwise comparison stats showed that the intact versus non-condition with one morphological layer was indeed significant in the central and CP, but then the intact 2 versus non, so here I'm talking about the black and blue in this column, it was not significant. We can visually see that. And when we compare intact with one morphological layer to opaque with one morphological layer, so just the black and red, here in this first column, they were significant in both areas. So that also goes towards our proposal of different lexical entries. And when we compare intact 2 with opaque 2, they are not significant. So visually, it looks like they are, but statistically, they're not. All right. And now for our third model, which had morphological layers as the independent condition. Here is the central ROI wave pattern and the CP ROI wave pattern. And again, we can see how the opaque condition has visually a higher N per 100. And the model is significant too, but the pairwise comparisons are not significant. So none of them is significant. So we could catch no significant brain pattern of the difference in processing one or two morphological layers. And this goes actually towards what França et al. Found in their study. They also didn't see any neuro data for this compositional addition of a morpheme after the access to the encyclopedia have been made, after the first merge plus categorizing morpheme had already been done. So our conclusions with all of this is that it does seem that restaurant and to restore have different entries in our mental lexicon. So our linguistic knowledge would not count with this unconscious etymology-based decomposition. And there seems to occur a type of lexical garden path when we access synchronically opaque words, such as restaurante. So we seem to try to process it as to restore, but then we don't, and then we have to come back to the encyclopedia. And then just a reminder that this is based on a priming study. And our behavioral data pointed to a rapid effect of the number of morphological layers, while our MEG data was not significant, was not sensitive to this difference. And then some limitations and open questions to finish are that we had a problem with frequency control. So the items from the non-condition were more frequent than the items in the conditions intact and opaque. So that might have caused an impact in our results. And then there's also the EEG temporal studies like limitations regarding this morphological processing that we were talking about, this like just compositional morpheme addition. This seems to be something that EEG is just not sensitive to. So maybe, this type of EEG study is not sensitive to. So maybe in study with brain oscillations with EEG might be something that would tackle this. And then we should also mention the individual differences because people have different life experiences, so their mental lexicon is different. And this might impact not only the frequency, but the etymological knowledge that we all have, that each of us have, sorry. And as an open question, we have, of course, we asked ourselves if the result would be similar if the target was kept identical between conditions and not the prime as we did. And we also asked ourselves if results would significantly change, if we could have had a better frequency control. And I did not say this, that we didn't have a very good frequency control lightly. I did not take this lightly because we did spend a lot of time working on the stimuli. It was just not possible. So this is why we ask ourselves if it is possible at all. But it would be really cool if we could come up with that. This is it. These are our references, and thank you so much.